Come on guys, let's do this problem right here. The question is asking when this object is about to move, what is the angle we are going to have in this side. So let's do this problem. So first of all we have to put all the forces acting on this. First of all we are going to have normal force in each of them. So we are going to have a normal force in the top one, and also we are going to have a normal force in the bottom one. It's going to be the weight of this one. So let's say normal force, this is normal force 2 and this normal force 1. But before I go do this, I have to do one more thing. Let's do the force. So when this object move this side, there's a force acting on, there's a force going to act on this side. Let's call this one F. So if this force is acting this side, it's going to have two components. One is vertical and one is horizontal. The vertical component is going to be f sine theta, because this is theta, therefore this is going to be f sine theta, and the other one is going to be, the horizontal is going to be f cos theta, and we are going to have two force of frictions in this case. This is so when this slide, this is the opposite side of the force, therefore we are going to have a force of friction right here. Let's call this one force of friction 1, and also we are going to have another force of friction right here. Let's call this one force of friction 2. So these are the force of friction, and let's start doing this problem. So first of all I would like to start with the bottom part. So before I go further, I would like to mention this one. N1 is going to be equal to the total weight of this object. So this weight is going to be, let's call this M2. So M2G gravitational force, M2 times G gravitational force, and this F sine theta is going to be, so for example, like when this weight is acting downside, so the reaction is opposite side, that's why this positive M2G. Since F sine theta is acting upside, the reaction is going to be the negative, so it's going to be negative F sine theta, and in the bottom we are going to have M1G plus M2G. So let's call this whole thing, so this whole thing is N1. N1 is equal to M1G plus M2G minus F sine theta. F sine theta, then we can start solving this one. So I would like to bring the bottom one, take the bottom part first. So if I take the bottom part and take the horizontal components, so sigma f of x is equal to 0 in statics, and if I take this direction positive and solve for this one, we are going to have negative f of r2 and negative f of r1. Also we are going to have positive 125. So if I bring this equal to 0, so if I bring these to other side, it's going to become positive, so therefore we will get f of fr1 plus f of fr2 is equal to 125. And now I can substitute these values. Before I go further, the general equation for the force of friction is normal force times mu s. So in this case we have the normal force and mu s is provided, so we can directly substitute those values. So first of all, for the force of friction 1, the N1 is going to be there, therefore N1 is going to be M1G plus M2G minus F sine theta, and for the FFR2 we have N2 right here, so it's going to be plus N2 is M2G minus, so also we have to multiply this one by mu s, because force of friction is n time mu s, so this is time mu s, and the second one is going to be f of r2, that is m2g minus f sine theta, also we have to multiply this one by mu s, so both of them are equal to 125, and mu s is provided 0.2. Since mu s is multiplying both of them, we can bring it to the other side and divide this one by mu s. So mu s is 0.2. Let's divide this one by 2 and see what the value we get. If we divide this one by 2, 62.5. So since this is 0.2, it's going to be 625. 625, and this one is so we took the m2 mu s to the other side, so we have only left m1g, m2g, f sine theta. So let's see how we can simplify this one. M1g, and if you see, we have m2g in the both side and f sine theta also in the both sides, so we can simply add them together and call it as 2m2g and minus 2f sine theta, and which is gonna be equal to 625. And if you calculate so m1, the weight is provided here, 30 kilogram and 20 kilogram, so we can substitute this value for this one, and if you g is going to be 9.81 meter per second square, and if you substitute those value to this one and find the final value, it comes out to be 686 newton. 686 newton. Therefore I would like to continue in the other side, so it's going to be minus 2 f sine theta is going to be 625 minus 686. So if you substitute this value, you will get 31 newton. So 31, and that's going to be negative, and therefore f sine theta is going to be minus 31 over minus 2, which is going to be equal to 15. So this is, so 25 is 61, right? 61 divided by negative 2, it's going to be 30.5 newton, and we have found f sine theta. So this is only the bottom part. Now we have to take the top part. So what's going to happen is, so in this case, top part is pulling this object to this direction, so there's going to be another friction force acting on this direction. Let's call this one FFR3. So this is FFR3, and this is going to be same as FFR2 because the normal force is same. That's m2g minus f sine theta, and the weight is also same, and the same mu s. Therefore we don't have to separately find it. This same thing, m2g minus f sine theta, and that multiplied by the mu s. So that's going to be the FFR3. Therefore let's calculate this one. So this is sigma fx1, the first block, and let's do the second block. So sigma ffx2, if I take this one, this is going to be 0 in statics, and if I take this direction positive and solve for this one, I will get FFR3 positive and minus f cos theta is equal to 0. Therefore FFR3, I can put this value for this one. So m2g minus f sine theta times mu s minus f cos theta is equal to 0. And if I take the f cos theta to the other side, f cos theta is gonna be equal to these values. You can substitute these values, since so f sine theta mu s, so f sine theta we found it here already, so we can substitute here to find this value. So what's you gonna get is m2g. M2g is basically m220 times 9.81 minus this value 30.5. You multiply this one by 0.2, which will give you f cos theta. Therefore that if you calculate this value, this comes out to be 33.1 newton. So we have f sine theta, f cos theta. Our purpose is to find theta. That's our question, right? What's the theta it's going to make when the object start to slide? So let's figure it out. So we can simply divide both of them to make a new connection. So f sine theta over f cos theta is equal to 30.5 over 33.1. Here f and f cancels each other, therefore tan theta is equal to 30.5 over 33.1. Therefore theta is going to be equal to tan inverse 30.5 over 33.1. And if you calculate this value using calculator, you will get theta is equal to 42.7 degree. So this is our final answer. That's the question is asking. So this is the angle this will make when the object start to slide. And that's it. I hope you guys like this video. See you next time.